Hi guys, this is a video that summarizes the steps of CADCAM using SolidWorks. So let's start with making a new file. Click on new button and make a new part. So we'll start with the CAD. So we go on the sketch and click on the sketch. We select the top plane. Then we draw a centered rectangle from the origin. Now we have to give the dimensions to this rectangle. So we select this side of the rectangle and give it the dimension 100 millimeters. And now we put the constraint on these two sides of this rectangle to make them equal. And now our rectangle, or now it's a square, it's fully defined. So we want to give it a third dimension. So we click on the extruded boss button, and the default height is 10 millimeters. So we'll just click on OK. And now this is a 3D object. Now we want to make a pocket on our 3D object, so we select the top face of the object and click on the sketch button. So let's make another center rectangle on top of this part. We start from the origin, and now we have to give the dimensions to this. We press Ctrl 8 so that we can see this working plane. And now selecting the Smart Dimension button, we give the dimensions to this side. Now we'll give the dimensions to the other side also. Yes, this one. So now our sketch is fully defined, and now I clicked on Extruded Cut, and I want to set the depth. So I selected 6 millimeters and click on OK. Now we have a pocket in our part. So now we want to make a window, so let's make another center rectangle in the origin of the object on the top surface. So now we'll give the dimensions to this rectangle again. So make it 20 for this side also. And now we want to cut through all material. So we will select in the features Extruded Cut, and we select here through all and we click on OK. So we get a window in our part also. So this is our part. We can move around and we can see the features of our part. Now we have to save it, give it whatever name you want to. So let's give it tutorial 1. And before moving to CAM, I will select all the operations that I did and I will add them to the new folder. I give the name part to that folder. So let's draw stock material over it. Create another center rectangle from the origin. Okay, now we want to set the dimensions here, so we will just assume that the stock material is 5 units larger than our part from each side. This is done. Extrude it over the part, but do not merge the result. So uncheck this merge result button, and this is our stock material. Now we will change the transparency so that we can see our part. Change transparency. Now we can see our part through the stock material. So we'll put this part also in another folder. We'll call it stock, so it looks cleaner in our working tree. So now we have to make the coordinate. So you can make this coordinate in CAM also, but I prefer making it here. So first of all, we'll draw some reference lines that will represent our y-axis and x-axis. So we are drawing 2 lines perpendicular to each other, and then we'll convert them to construction lines because we don't want them to be the part of our drawing. So let's select both of them by pressing the Control button, and then go down here and click on the For Construction button. And now we have these 2 lines which are not part of this drawing, and they're converted into construction lines. Now go to the features and select reference geometry. So making the coordinate system here, we need to have a point here. And so you can see that it's not selecting the intersection. So let's make a point, select these 2 lines, and you'll see automatically the point is emerged, the pink color. And now we have the point. We will do it again, coordinate system, and we have to align our y-axis with the vertical line that we can see. Yes, with this one, And now our coordinate system is aligned as we want it to be in our machine. Click OK and put all these operations into another folder. We will name it as coordinate. Now it looks cleaner. Save it, and then we'll go to SolidCAM. Click on New and Milling. Now we will see a message that says that the part is automatically defined. We don't want our part to be automatically defined because everything is messy. The coordinate system is somewhere else. We don't want our coordinate system to be there. So let's change the CAM settings first. Go to SolidCAM part tab and go to CAM settings. On automatic CAM part definition, just uncheck all these options. Click OK. So we'll exit this SolidCAM and then we'll reopen our part and reopen the part in SolidCAM. New, milling. So here we go. We have the part in SolidCAM. Our machine is already defined, but no coordinate system and no stock and no target is defined. So we define the coordinate system. We click on this select coordinate system button, and then we see this already defined coordinate system that we did in SolidWorks. We select it. Now we have to define the Z level. So for me, I'll define it -2. You can select it as whatever you want it. Okay. Now I'll define stock. For defining the stock, you need to change this defined by thing to 3D model. Click on any of the edge of your stock material. We click on this edge and it's selected. Click on OK. Now we define the target. For defining the target, click on any of the face of your stock of your target material. It is done. Click on OK. Our part is defined completely now. Now we have to do the machine operations here. So let's select some operation. We actually want to make a profile pocket. We need to select the geometry. The pocket is defined by the closed contour or the edges. So we select these inner contours. We can select the upper contours also. Click on yes. Now we have defined one chain. An important point here is the direction of the arrow. So it's somehow upward. So we assume that our tool will be cutting on the left from the left side of this pocket. Click on OK. We have to define the tool now. By default, bull nose mill is selected. No, I don't want this one. I have a 6mm end mill, so I'll define another end mill with 6mm diameter. So you can set the feed rate in the tool data tab over there. I'll do it later. Okay, select the levels. For me, the clearance level is same as the safety distance, so I'll just put 2. I have to define upper level, which is 0, and the pocket depth 6. And I want to make it equal step of 2mm. Let's go to technology that will define how we want our machine to cut it. We will simply select the contour, which is by default. We set this wall offset and island offset and floor offset, and we want these things to be finished, wall and floor. You can select the offset values and whatever you want to change it. Now this link will define how our tool will enter the part. So I want it to enter in arc manner. So let's calculate it and then simulate it. Let's play the play button. This is how our cutter will go. Increasing the depth, doing the pocket, increasing the final depth, and one more time. So we are finished with it. So we can check, we can verify with like solid verify option. So this is how our part will look after this operation. We have the pocket. So this is a more closer look actually. So this is it. We'll exit it because it's done. Now we want that window also. So we'll use again the profile operation. In fact, okay, profile. Now we have to define the geometry. Now this is a mistake that I did while I was making the video. Okay, not this one. In order to define the geometry, we need to select in a sequence. So I cannot select this one. I have to select the side with the other one. Yes, this one. It's okay now. This is a close contour which I will change it later on because I want that small window to be selected here, not this big one, because we already did this thing. Okay, let's select the tool, the same tool, 6 millimeters. I don't want this tool number 1 and tool number 3 here, so I'm trying to delete this. I cannot delete this number 3 because right now I am in that operation that initiated that tool. I cannot delete it right now. I can delete it later on, so I'll delete it later on, not now. Let's select the levels. Clearance level 2. Now this is the profile depth, which is 10. Okay, setting these parameters, calculating it, and simulating it. Now the simulation will tell me that this is wrong geometry because I have already programmed this in the previous operation. What I'm going to do is I'll click on geometry and I'll change it. Edit it, delete that chain, and I will select a new one, this one. So let's select this edges. I cannot select this one. Oh yeah, let's select this sequentially. Yes, so the rest of the things are same. I just changed the geometry, so I can now calculate and simulate. Rest of the things are same. Calculate and simulate. So we can see that the tool is going in following this arc, and it's coming out following this arc. So it will take some time actually. So let's first see this in the solid verify section. So let's change the lead out. Okay, first of all, the tool was going from upper level 0, but I want it from this point, which is actually already 6 depth. And I will change the lead out method. I'll just remove this lead out thing. None. Calculate and simulate. Now the tool is starting from the level 6 already, and this is fast. We have the window now. And now we can see it together. So this is the sequence that our tool is going to follow, because the tool is same, 6 millimeters in diameter. So we don't want to change our tool for this operation, but if you have different operations, you can put this change tool thing over here also. This is the window and this is the finishing step. And so now we have a pocket and a window also. Now I want to try to delete that third tool. I can delete it right now because I didn't use it. Okay, for this I want to show you about the feed rate thing. Now I cannot change the feed rate because I am using this tool in two operations. So at the very first stage, let's say I'm describing another tool, this tool 1, I can change it right now. So whatever feed rate I'll select here, if I use this tool 1 in some other operations, it will be same. But since in the beginning I didn't change it, so I cannot change it right now also. Okay, I'll go again and I'll delete tool number 3. It's done. I want to save it actually. Select. Okay. And this is it. Select both of these operations and calculate and find the G code. So it said that they are already calculated, so I just press no. Okay, I'll just give some file name here. Click OK. And the G code is here. And the this G code depends on the machine that you have selected. So this G code is compatible for Mach3. I have tested this G code already. There are many post processors for Mach3 available on the internet, but there are some problems in the other post processors. I hope you enjoyed this video. Thank you very much. Bye.